Yay, recording. Did you guys talk about symmetry in Algebra 2 last year? Okay, 2 people are saying yes and absolutely no one else is moving. Okay. Hi. Tim, you're next to Kavoni. Okay. So even means symmetry with respect to the y-axis. What does that mean visually?
Split it, then both sides.
So if you fold it down a vertical line, there's symmetry. Any vertical line or a specific vertical line? Folds over the y-axis and the y-axis only. So this one, wow, this right side or left side folds onto the right. Jackson, what about that? Is that still even? No. If I fold it over the y-axis, it's gonna look like that. Did not fold on top of itself. So this, even though it's some kind of x squared thing, it didn't fold onto itself. Even, symmetric to the y-axis and the y-axis only. Eric, odd means symmetry with respect to the origin. What does that mean?
Symmetry, like where, like how the graph starts out.
Okay, so one of these other 2 has symmetry with respect to the origin and one of them doesn't. Which one?
I think the third one is symmetry.
Okay, symmetry with respect to the origin is that one. Let's see. To visually show you what that means, if I take it and turn it upside down, do I see exactly the same thing? Ready to do that again? Turn it upside down. Do we see the same thing as the original function? Yes, we do. On tests, I can tell that you guys heard me say that because you're looking at it and you do this. Turn it all the way upside down. That's what you gotta check, is that it spins around that dot. So there are things that, this is a new function property that we want you to know and understand and be able to identify. So visually, how do you identify that it's even? It folds like a butterfly over the x-axis and the y-axis and the y-axis only. If it's odd, it spins around the origin. Turn it 180 degrees and it turns around. Tim, can you take that here, but and then this one is in either. It doesn't fold or spin around either of those things. All right, so today we need to figure out how to determine if a function's even or odd graphically and algebraically. Homework is to finish page 16. Monday we're going to have a checkup or feedback card, and it'll be on Delta Math. There'll be another one on Delta Math. Okay, so this is what's coming up. Dates and everything. So today is the 10th. So in another 10 days, we're going to have another quiz. Okay. Algebra 2, they should have talked to you about how we deal with name functions. We name them by the highest degree. Degree is the highest exponent. So Coco, in this first one, no, is this in your packet? It is not, right? Coco, in this first one, what's the degree? In that guy, what's the highest exponent? what's the exponent? This is a coefficient. So I want the exponent. Aiden? 2. The highest exponent is 2. So this is second degree or degree 2. Savoni, are you looking in your packet so you can you read your packet or go? It's not in the packet, never mind. He said, I can't see because I don't have my glasses. And I asked him something's not written on paper in front of me. So sorry. So, Chloe?
Mm-hmm.
What's the highest degree in the second one? 5. Bless you. What's the degree on the last one? 1. It's not written, but the exponent on there is a 1. Okay, so these two have odd exponents. They might be odd functions, but they don't have to be. This is an even exponent, but it doesn't have to be an even function. So be careful. A lot of times, these guys, those guys are all even functions. Now they're not. Like, I can tack something on that ruins everything. Okay, so we are finally back on the page. Page 14. I think we should do the first one together. Luca, what's the domain of this function? That 1 over x squared. Can I put in every single x value?
Maybe
Perfect. So write it down, guys. Why did he skip over 0? Because there's a vertical asymptote. When I plug in 0, I get 1 divided by 0. If I type that in on the calculator, it's going to bark. Seth? What's the range where all the y values start from the bottom and go up? Okay, Jackson, round brackets, square brackets, mix and match? Both round, because we don't actually get to 0 and we don't ever actually get to infinity. Both round. Will, do I have any asymptotes?
No.
None? No? Says also no? Chloe?
There's 2, one at y equals x and one at x equals 0.
Okay, at x equals 0, there's a, that's an asymptote, and we also have a horizontal asymptote at y equals 0. So what asymptotes are is vertical ones, they're going to have those, one of the y values goes off to one of the infinities. Horizontal asymptotes mean at the end of time it looks like the y value is settling off, riding off into the sunset at a specific even height. Kylie, is this bounded in any way?
Yeah.
Where? Below. It's got a floor, it's got a bottom that it cannot go below. End behavior. Sonia, how do I do right end behavior?
Well, right and behavior first and goes to, it starts from 0 and goes to infinity.
Okay. So with limits, we want this to say the limit is x goes to positive infinity, because that's on the right. Sam, where does the y value go? The y value?
Oh, wait,
The y value's hovering right there, which is how high?
like 0.
Like 0. So that's right end behavior. Actually, does it look like the left end behavior's any different? No. So what is the one difference I need to do in my setup? Negative infinity. Left end, as we go super duper that way, goes to 0. Those are my end behaviors. So the new one is a symmetry. Does it have odd symmetry? If I pick it up and turn it over, Adar, is it gonna be the same thing? Is it odd symmetry? Can I spin it around the origin and see the same thing? So if I turn this upside down, this will be interesting. Oh, it's letting me. Turning it upside down. Does it look like the same thing? Doesn't look like it to me. So, it's not odd. Is it even? Does it fold over the y-axis?
I think it's even,
He's not sure about that. Manny, what do you think?
Yeah, it's even.
Yes, it's even. Folds over the y-axis. Okay. With your partner, can you guys do this one on your own? Brianna?
For the end behaviors, would there ever be a time that you use coordinates instead of just a whole one?
End behavior, like a coordinate is an x and a y value, end behavior is when x is super duper positive
Not a
infinity.
coordinate, but like, you know how you list for like the range and the domain?
It's always just gonna be somewhat, it's either, it's gonna be a number or an infinity.
Like, is it log for the side of the positive versus
Round.
That you probably use 0 on this.
Plug 0, so it's gonna cause a divide by 0 problem. Sorry, hold on, yeah.
For the end behavior, what did you say, 0 or?
Okay, what is, okay, left end behavior, x goes to negative infinity. So what's the y value when x is 2, negative 2? So what is it? 0. Does that make sense?
Yeah.
Sorry, Lily, did you have a question? Oh, Amy did, sorry, I heard the voice of Mr. Animal. Yes, No. Yes. If I said, how do you undo add 3? Subtract 3. So this is kind of weird. How do I undo e to the x? I undo it by doing natural log. Do you know what logs are at all? It's something special. Yeah. It's getting a little bit bigger.
So it is
Really, really
positive.
big. Okay. Log, ln, this is ln, natural log, is log base e, it's the inverse function of exponent. And some of you are like, what is that? Some of this is to remind you of stuff. This natural log, it's getting a little tiny bit bigger, really, really slowly, but it's getting bigger and bigger and bigger forever. Where does it look like the domain begins? Can I find natural log of -18? No, where does it start?
Looks like it starts at 0.
Would it be a square bracket on the 0 or round?
It would be round.
It would be round. You cannot do natural log of 0. Okay, Tim, what's it look like the y values are? They're coming up and doing that. What is the range?
0 to -infinity.
All the numbers that could be numbers, -infinity to infinity. Jacqueline? Asymptotes.
X equals 0.
Perfect. There's an asymptote of x equals 0. And some of you, because log grows so slowly, you're like, oh, doesn't it cap off? It does not. So there is not a horizontal, just a vertical at x equals 0. Boundedness. Does it have any bound? Will is saying no. Boundedness is, does it have a floor or a ceiling? No, it doesn't. We don't care that it's chopped off on the left side. Which, Sasha, what does that make the left end behavior? You guys hate these because you're like, there's a left end. It ended right there. But end behavior is as x goes to -infinity. So those of you who asked, what's the left end behavior? I'm like, well, at the end of time, let's just check what's the y value when x is -2. Doesn't have one. What is it when it's -5? What is it when it's -10? Doesn't have one, doesn't have one. So what is it at infinity, -infinity? Doesn't have one. Manny, what is the right end behavior of this gonna be?
As it goes to positive infinity. It goes positive infinity 1.
Okay, yeah. Do I have any symmetry? Is it even, is it odd, is it neither? Keith, what do you think? Does it fold over the y-axis, does it turn around the origin? Correct, doesn't have either one. How you doing? Yeah, yeah. Okay. Cause it's about to get real, yeah.
Oh, there you go.
Gotta wait till she comes back. All right. So that was graphical and a reminder of some properties. Algebraically, we're gonna have to prove these as well. And you guys are, we'll say minimalists, or those who like to be efficient, or also known as potentially lazy. You guys hate this part. Mathematically, if I tell you the function's even, this is the math test that I need to do. If I tell you something's odd, this is the math test I need to check. So on page 15, flip the paper over, perfect. So in both of these tests, I need to know f of -x. So for number 1, this is what we're gonna do. We're gonna do f of -x. But actually, before we do that, out there, f of -1. What is f of -1 in this first problem? X squared minus 5. When I plug in -1 for x, what do I get? Okay? So what we do is we put in -1 and we square it, and then we subtract 5. -1 times -1. Positive 1 or -1? Which one? Positive. Positive 1 minus 5? -4. Okay. So the harder question, Sam, plug it in -x for x. And using parentheses, what is negative x squared?
2x.
Negative times negative is gonna make positive or negative, which way? Positive. If I have an even number of these, it's gonna be positive, then x times x is x squared. Okay. So on your paper, it's written, the test to see if something's even, Seth, does f of negative x equal f of x? Did these come out to be exactly the same?
Yeah.
Yes. So what can I conclude?
It's
Okay, yep, and you're gonna see this on the answer key. Does anyone know what these 3 dots mean? Therefore, thank you. Apologize for the handwriting. I really did have penmanship. That was a thing back in elementary school. I'm used to using a pen to write, not my finger. It's kind of stupid. Yeah.
Why did you do that first part where you plugged in -1?
Just for you guys to understand like what we need to do for plugging in, because some people don't know how to plug in the negative x, so I wanted to check, could we do it with a negative number? So I didn't need it, you're right.
Okay.
Leo?
Wait, how did you get rid of the -5? Like, how did you go from x squared minus 5 to the, like, final?
Okay, so f of negative x, that's in both testing if it's even or it's odd, I need to put in a negative x. So instead of x, I'm putting in a negative x. Negative x times negative x is positive x squared. The negative 5 was there, it's still there, it's still there.
Okay.
So this right here is f of negative x.
Okay.
And I asked Seth to compare, does f of negative x equal f of x? And he did the, yeah. So it's even. Okay. Brianna, how do I check the second one? What's the first test I should do? See if it's even or odd. Both of them say, I need to know this value. So what should I check? I want to find f of negative x. Well, in this case, the functions have g. And you guys do that one on your own. G of negative x, what does it come out to be? Write some stuff down. Yes, ma'am. Okay, Aiden says it's odd. Everybody agree? Leo agrees. Helena says yes. Be really careful with these. Adar, what is negative x times negative x times negative x? Negative x squared, x cubed that is? Keep subtracting negative x, what does that become?
So,
If you're subtracting a negative, what happens to the signs?
it's positive.
It becomes positive. What can I do with that negative sign in there? Is this 5 minus x cubed? No, it's 5 times negative x cubed, so that negative's gonna squirt out front. of negative x equal g of x? Eric, are these the same? Does this and this, are they equal? No. So right there, I know it's not even. Hannah, looking at the notes at the top, I need to do a different test to see if it's odd. So right here, this didn't work. What's the other thing I need to find?
Negative g of x.
Yeah. All right, so let's find negative g of x. Negative g of x is all of that stuff with the sign swapped. So nor distributing the negative, what do I get? Distributing the negative to each piece in here, what do I get?
I believe that was
I get negative 5x cubed plus x. All right, so Leo, now testing, looking at these guys. Does g of negative x equal negative g of x? Does this equal that? Yes. So, what Aiden said a long time ago, g of x is odd. Why is it odd? Because this thing, g of negative x equaled negative g of x. Okay. Can you guys try these first two? Mommy, are you okay with the second paper? See that? You think you're- I don't. Sure. You okay there, Matt? I don't see a lot of pencils over it. You have them done? Very good. It's the very, very first check that you need to check either case. Well, to see if it's even, I need to see if this equals that. To see if it's odd, I need to see if the same thing equals that different thing. What thing should I find first? Okay. So this one, we're gonna find h of negative x. So the very first test for any of these things. What happens when we do negative x? Negative x squared becomes x, positive x squared. 4 times negative x is negative 4x. Are they equal? Grady's like, no. Because they're not equal, it is not even. Okay. Nora, what do you say the next test is that we gotta do?
We could check if it's on.
Check to see if it's odd, which is just multiplying the whole function by a -1. So I need to distribute that -1, and I get negative x squared minus 4x. Does h of negative x, this stuff in green, equal sorry, so do these two equal each other? X squared minus 4x, does that equal negative x squared minus 4x? No? Sasha says no. So what is it? It's a neither. Adrian, did you have a question? No?
Would it cover
Yep.
like checking if these are even or odd for like next like section?
No, it's not that long.
Okay, I was about to
So,
say.
I mean, these checks aren't that difficult, but some people have issues with negative signs and they get all mixed up. But the big thing is, I need a conclusion from your work. So on the next exit card, on the next quiz, you need to say what you're doing. So, yes, Seth?
When is the next exit card?
In a week. So, Will, how do I start the check for number 4? Is it even, is it odd, what do I check first?
You check if it's even.
Okay, so the test to see if it's even is doing
You make J of negative X.
J of negative x. Okay? So Manny, doing that, -2 times negative x cubed, what is that gonna be? Positive 2x? Is there anything wrong with that? Negative x times negative x times negative x. How many x's? 3. And there were 3 negatives, but there was a negative there, so I do agree it becomes positive. Leo, what do I do with the 4 times negative x?
It becomes -4x.
All right. So Chloe, does j of x equal j of negative x? No. So Tim, what is the conclusion? It's not even. Eric? You show me to this. Matt, what's the other check? Because it's now not even, what do I need to test?
You need to test if it's neither.
Okay, so what's the other check? I need to do another arithmetic thing.
Negative JX. Oh, yeah.
Negative j of x, which is changing the signs of everything there. Distributing the negative, I get positive 2x cubed minus 4x. Does J of negative x equal negative J of x. Is that true? Luca, is that true? So J of negative x is two x cubed minus four x. That does not equal, it does equal? So Eric, what is the conclusion because those two things are equal? Odd. So a hint, often if it's an even exponent, it's either even or nothing. If it's an odd exponent, often it's going to be odd or neither. We can be mean and throw in absolute values, which can make odd functions suddenly even. Leo, what's your question?
So you know when you like, we said like the last part, like that negative jx isn't equal to the last part of j negative x? But like for number 3, we didn't add, like it was, is negative jx equal to j, like the first part of the, you know what I mean?
Okay, so is it even, says the original thing. Is the original thing equal to that?
No.
J, and it's
But-
not.
But like, so like I understand like, so when we did the negative jx, we asked if it's equal to.
This guy.
Okay,
That's what we're
so-
checking. And 2x cubed minus 4x, 2x cubed minus 4x, dead on the same, therefore it's odd.
Okay.
Okay. So I would like you guys to put these up. Actually, just the first one, number 5. It's the first test that we need to do. Are those equal? Back line says no. So it's not even. Look at what we need to check. What else do we need to check? Distributing the negative, what do I get? Sonia, what do I get when I distribute the negative?
Negative x cubed plus 6.
Kylie does m of negative x, so this stuff, does that equal negative m of x? Does it equal? No. Therefore, what kind of symmetry does it have? Neither or none. Six, I have a question. Actually, before we do that, what is 2 to the 0? Okay, Nia says 1, someone else says 0. What is 2 to the 0? Anything to the 0 power, except 0 to the 0, is 1. Do you guys know what 2 2 to the negative 1 is? Is it negative 2? 1 over. So negative exponent means it's in the wrong part of the fraction. It becomes 1 over 2. 2 to the negative 2 is 1 over 2 squared, which is 1/4. See, you remember negative exponents? All right, guys, homework is finish page 16 through page